Hello, grade 10 science. Just wanted to reshoot this Unit 6 intro video. I don't know if you've already watched it, but I made a little bit of a change to the guide that I wanted you to look at. Nothing major has changed in the unit. I basically removed a little bit of the worksheet, removed a little bit of the work. Some of the equations were not applicable to what we had learned in the unit, so I just wanted to make a change for that. Everything is the same as before. Basically, we're wanting to go through what a chemical reaction is and how we write out equations for chemical reactions and how we balance those equations. Basically, in a chemical reaction, you have two reactants, two things that come together and create a chemical reaction. So this one right here would say hydrogen plus oxygen becomes water. Okay, so these two are the reactants right here, hydrogen and oxygen. This arrow is the actual chemical reaction, and then water would become the new substance, because for a chemical reaction, we have always created a new substance. That happens in four different ways. So there can be four different kinds of chemical reactions. Sometimes there's a synthesis reaction where two reactants or two or more reactants combine and produce a new product. We have a decomposition reaction where there you have a product that goes through a chemical reaction and becomes two separate products. So basically a substance that goes through a chemical reaction becomes two simpler compounds or elements. Okay. Then you have a displacement reaction. This is where one element takes the another place of another element in a compound. So you have copper plus silver nitrate. It ends up turning into copper nitrate plus silver. So as you can see, nitrate moved over to join the copper and left silver by itself. Then you have a double displacement reaction where you have a compound and a compound that come together and basically switch an element. So silver nitrate and potassium chromate came together and it became silver chromate with potassium nitrate. So they basically just switch places. But anyways, we'll go over that more in the seminars. You need to know these four. But then we need to get into this balancing chemical equations. And basically what we do is we'll take the name, the written form of a chemical reaction, and we will turn it first into a formula. And all this is this is just a review from Unit 5. We know how to take barium chloride, and we know how to, by using the crossover method for an ionic compound, we know how to get that down and written into a formula. Then we put our plus sign down, and we change sodium hydroxide, and we write down its chemical formula. And we do the same for all four of these components in the chemical reaction. And then what that gives us is it gives us a chemical formula for that reaction. Now what we have to do is we have to take that and we have to balance that to make sure that the same number of atoms that are found over on this side, there's the same number of atoms in the new substance that's been recreated. Because if that doesn't change, we never lose atoms or gain atoms in a chemical reaction. They always stay the exact same amount. Now the atoms might be configured differently, they might switch differently, they might make new compounds, but we don't lose any atoms, we don't gain any atoms. So always we should have the exact same amount of atoms in the final substance that's been created as we had in the initial reactants. We'll explain that more in the seminars as well. One of the changes I made to this unit is this is a very important table that you basically have to memorize, because when we're writing these formulas up here and we have a hydrogen in it or we have a nitrogen in it, we have to, we can't just look this up on the table anymore. Now we have to know how many atoms. So if we have a water, for instance, and it's hydrogen and oxygen, we know that that hydrogen is going to naturally have two in it. If it's a barium chloride, okay, we know that chlorine is going to represent two atoms just by saying chloride. Okay, as you can see right here, just basically that's a given, that's a natural. We're going to end up with that. Okay. So, so when we're writing these in, we want to make sure that we remember what these amounts are. And the good way that we can use that is we can use this Hofbrinkel. It's pronounced Hofbrinkel, but basically any of the elements, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine, all of these have a value of two atoms when they are found in nature. So whenever we're writing the chemical equation for a word equation that includes any of these elements, that's the atom count. You do not use the periodic table to count the atoms. If it's not in this table and you see it, this element in a chemical formula, then you go to the periodic table and you use its symbol to figure out how many atoms are involved. Okay, so I hope that makes sense. Okay, so if we're writing out a chemical equation and we see sulfur or sulfide is one of the elements in there, then we want to put that as a value of 8 in our chemical equation. We don't want to go to the periodic table to do that. Alrighty? Okay. So just make sure we know this cheat for this table. If it's not in Hofbrinkel, we're not going to cover it. Okay, so phosphorus we're not going to use, selenium we're not going to use, sulfur we're not going to use. We're just going to basically be using these ones. This is what you need to know, these ones that have this value of 2, okay, by using Hofbrinkel. Okay, then we get into this is goes into how you write the solution or the equation or the formula out. So you start with your sodium chloride plus sodium plus chloride, and you put these together, and this is how you write out the formula. Then once you have the formula, we have to balance the equation. As you can see right here, we've only got 1 atom of chlorine in the original compound, but we had 2 atoms of chlorine in the substance. So this reactant went through this reaction and became this new substance. But the atoms aren't the same. So now what we have to do is we have to do what's called balancing the equation. We have to balance the atoms in this equation. And it shows you how to do that down here. It takes you through a step-by-step process of how, using these tables right here, of how to balance this until we end up having this with everything in there on the reactants and product side being equal. So it's not balanced here. It's not balanced here. It is balanced here. 2 of each, 1 of each, 2 of each. And this step-by-step process will show you how to do that. I've also put a very good video on the website right here. This guy does great stuff. He draws everything out for you, shows you diagrams of the atoms switching places on each side. So you're not just, it doesn't just look like math. You can actually physically see the atoms in the reactants switching sides to the substance, and then he balances those atoms by dragging them back and forth. And it's a really cool video. I highly recommend you watch it. Okay? If you have any questions, please let me know. Sorry, when you get to the end here, the learning check is for marks. These are very simple balancing equations that we can do. And we're going to come down here. We're going to balance these. Don't stress out too much. There's some difficult ones here. Okay? If you have any issues, just leave it and go on to the next one and come and see me, and we'll cover it together, get it fixed up so you can get a good mark on this deal here. Okay? But these are, for the most part, these are some pretty easy equations to balance. Just use this kind of table system of doing it right here, and you won't go wrong. Okay? Let me know if you have any questions.